All right, so log 3x plus 1 minus log 2x minus 3 equals 1. So let's see. What did you do first? What did we do first? Apply the property that goes like that, right? So the difference of two logs is the log of the quotient. And then, Colin, you're supposed to apply the definition of logarithm. So you should have a 1 over here, which I think is what you were working with, maybe.
Oh, shit.
There's a base 10, so it goes like this. 10 to the first equals 3x plus 1 over 2x minus 3. That's the property we use all the time, right? A lot of times I get a 1 over here, right? It's 10 to the 1 equals that. 10 to the 1, 10 to the power of 1 equals the input of the log, which is the output for your exponential piece. And then if you solve this guy, you multiply both sides by 2x minus 3, and that should give you this linear expression. And then what do we want to do with that? Distribute 20x minus 30 equals 3x plus 1. So 17x equals 31, which means x equals 31 over 17. Okay, now, is that a solution? Well, we should check it. But as long as when I plug that into here, I don't have log of a negative, I think I'm probably okay. But you could always check it to make sure it works.
I always get, like, when I try to check them, I always get, like, an error.
Error?
I don't know what I'm doing.
You'll get an error if, when in your calculator, you plug in log of negative something. I don't know. At some point, if you plug it in log of a negative, then that's a problem. So there's a chance that there's no solution. We get these extraneous solutions sometimes. If I plug this in and I end up taking the log of a negative here, then it's not really a solution. But if you have the right answer for this problem, you shouldn't have that issue. You should be able to run that number through this, and it should spit out an answer.
I have that number.
And you got an error?
Yeah.
I'll look later what you're doing in your calculator, because it should give you an output there.
Okay.
Any questions on number 1? Say that? Oh, yeah. If you gave me a decimal answer, I think I was looking at some of your quizzes. It should have been like 1.8 or 1.8 something. Yeah. Very good. Okay, how about the next one? Number 2 goes like this. First thing I'm going to do is isolate my exponential expression. So I got 14e to the 2x equals 13, and I'm going to divide by 14. So I've isolated my exponential expression. And now for the real step, the important step, take the natural log of both sides. So that's the algebra that I want to do, the natural log of both sides. So that gives me the property here is the bases line up for that expression. So that means the natural log of e to the 2x is going to just be 2x. And that's equal to the natural log of 13/14. And then I can divide by 2. And if you gave me this as your answer, that would be correct. Or you plug it into your calculator, and you get
Negative 0.03.
negatives are okay for logs. Remember, you can't take the log of a negative. There's a difference. This is a negative number, right? Because the natural log function goes like this, right? So that's the point 1, 0. So anytime I take the log of something less than 1, like 13/14, it gives me a negative number. That's okay, right? Don't mix that up with the concept of you can't take the log of a negative. The input can't be negative, right? There's no inputs that are negative. The output can be negative, right? So this is a negative value, negative 0.037 is what we're getting. So x equals negative 0.037. So yeah, the next question is that acceptable? Well, plug it in. What's 14e to the 2 times negative 0.037? Is that, does that give you an output?
13.
The answer is yes. It gives you an output, right? You can take e to a negative, that's okay. You can't take log of a negative, but you can have a negative exponent, that's fine, right? And that's what this solution is representing, an exponent, right? So negative exponents are okay. Negative in the log, not okay. Good question. Who's got questions? It's going to be a long video. Okay, let's see. Moving on.
Is this video like recorded?
It's recording right here, yeah. I think. We'll see. It's the first time I tried it. So this one goes like this. I got to sum. There's two ways to do this one. Did anyone just plug that into your calculator and get a decimal to start? You could have done that, right? It's kind of set up. This is what we get in the habit of doing, right? But I could have just taken the natural log of 4 with my calculator, subtracted that over, and gone from there. You get the same answer as we'll get here. What's the next step? Vincent, what's the next step?
You do 10 squared, right?
Not 10, because the base is E.
Oh, E.
E.
Go to E.
E the second equals 4x.
I actually got this one right.
And then you divide by 4, and then you're done. Divided by 4, divided by 4, and there's your answer, your exact solution. The decimal would be, I don't know, about 2 point something. 1 point something, 1.87. 1.847 looks about right.
Okay, I did
1.847.
I did describe that wrong.
Colin, you got 1.359.
What did I get?
I don't know how I did that.
You got the work right.
I put this. Oh, my freaking calculator.
You got the work right.
Did I get it?
Nah, it's not degrees. It's got to be something else, right? Because there's no angle measurement here. That's the trick.
Right.
Yeah. So it's something you got the work right. It's just you got a weird answer. E squared over 4 should be, well, if everyone else has it,
I did E squared and then I divide. Yeah.
Did I get it right?
1.847 looks like.
I don't know.
Okay.
Oh, it's because I realized when I turned my calculator in, I did 2E rather than E squared.
Yeah, that's it. 2e. E squared. E squared.
Yeah.
Okay, moving on. Last one. If I set this one up, you should have, let's see, currently 12,500. That's your initial. Your rate is 0.012, and you want to know when it's going to be 20,000. So there's your setup. All right, there's your setup, and once you have the setup, it's just like the previous problem. Right, so this is your exponential growth, the initial value, and then your rate times t. And then you solve that guy. So if I solve this guy, I got to divide both sides by 12,500, and that gives me 200 over 125 equals e to the 0.012t. And just like the previous problems, we take the natural log, and that kills my exponential expression, which is what I want, and I have this.
You could have 40 over 25.
Yeah, that reduces better. Yeah, it reduces better. But in the end, you're going to give me a decimal for this one for sure, because it is your given decimals or it's an application problem. So you would never say the natural log of 200 over 125 divided by 0.012 years. All right, that wouldn't make sense. You would just give me 39 years. 39 years. What else do you got there? Okay. 39, about 39 years.